Hey YouTube, welcome to another cloud computing news. Today is Tuesday, February the 6th, 2024. So name's a little bit different. I'm going to drop the cloud in a hurry thing. We're going to go with cloud computing news. Hopefully that makes things a little bit easier to find on YouTube. This video actually was recorded yesterday. I'm re-recording it today. I talked so long yesterday and just went all over the place because I'm really excited about what I'm going to talk about today. But I just was all over the place yesterday. There was no salvaging what I recorded from an editing perspective to make something that was publishable. So I'm going to try to be a little bit more focused today and get through all this content, but do it in a very quick and concise way. What we're actually going to talk about is the Rust programming language. So a little bit of a deviation from, what we typically talk about in terms of cloud service, a launch of a cloud service, or, an additional feature to an existing cloud service. But I really want to talk about Rust. I thought I'd put this video together and walk through some of the things that, things I've seen in the past. But the thing that kind of catalyzed this is this post that you see in up here in front of us, which is uh, an announcement on the Google blog about Google making a $1 million investment in the Rust Foundation. So the Rust Foundation stewards the Rust project. The byline in this article, from my point of view, is right here. We were delighted to announce that Google has provided a grant of $1 million to the Rust Foundation to support efforts that will improve the ability of Rust code to interoperate with existing legacy C++ code bases. So why does Google care about interoperability between legacy C++ code bases and Rust? I'm actually going to skip over the second tab and go to the third tab. So this is a blog post from Google's security. It was published in December of 2022. What Google's saying here is that, as of Android 13, they began to introduce components written in Rust into the Android code base. And there's a lot of interesting data in this article. I'm not going to go through all of it. Of course, this article is linked in the description, as all of the articles are that I pull up and talk about in these videos. This is the really interesting part. And I haven't seen any updated statistics relative to, this assertion here. But as of 2022, when, Google had just started to introduce Rust into the code base, Google says, to date, there have been zero memory safety vulnerabilities discovered in Android's Rust code. We don't expect that number to stay zero forever, but given the volume of new Rust code across two Android releases and the security sensitive components where it's being used, it's a significant result. It demonstrates that Rust is fulfilling its intended purpose of preventing Android's most common source of vulnerabilities. So the thing that like really is worth double clicking on here is that not only are they using Rust in the code base, they are saying here that they're actually using Rust to build security sensitive components of the operating system. So I don't know what they are. There may be another post somewhere that kind of correlates this, but let's assume that these are things that handle cryptography. These may be things that handle communication with a baseband processor in the phone. Whatever they are, they're very security sensitive features of the operating system. And Google saying, hey, we're writing this stuff in Android. And to date, as of 2022, across two separate Android releases, zero vulnerability. So that's huge. I mean, the vulnerabilities that we've seen in Android and in iOS, over the years have been impactful to say the least. The Google saying, "Hey, we've used Rust over two separate versions of Android, and we've seen zero vulnerabilities, or at least memory safety vulnerabilities." I should caveat that. That's significant. So it's a big deal. Like this is why Google has made this investment. So I'm going to switch gears a little bit, and this is something. This blog post is from 2020. It is really interesting, and I think it's worth looking at some of the things that are mentioned here by Amazon. So for those that don't know, Amazon is actually using Rust for some of the backend components of AWS, or backend services, I should say. So the title of the post is Why AWS Loves Rust and How We'd Like to Help. For similar reasons at AWS, we increasingly build critical infrastructure like Firecracker VMM using Rust because of its out-of-the-box features, reducing the time and effort needed to reach Amazon's high security bar while still delivering runtime performance similar to C and C++. But what Amazon's saying here is, we're authoring backend components or components of AWS in Rust, and we have a really high security bar, obviously, because, impactful security incidents on the AWS service, or core services, or on the platform, that's bad for business. So if they're going to write components like this, they need to be secure. But as of 2020, AWS says, we are actually using Rust in services in addition to Firecracker, which was already mentioned, S3. S3 is the one that everybody knows. That and EC2, CloudFront, Route 53, and more. Recently, we launched BottleRocket, which is a Linux-based container operating system, also written in Rust, which is a really interesting component of EKS. If you've never taken a look at it, take a look at it. Our Amazon EC2 team uses Rust as the language of choice for new AWS Nitro system components, including sensitive applications such as Nitro Enclave. If you're unfamiliar with Nitro Enclaves, it's basically a feature or component that lives inside of EC2 for running verified workloads. So this is like one of the most security sensitive services or features built within the EC2 platform, and Amazon is using Rust to deliver those features. So once again, I mean, it's really compelling from a security perspective, talking about, Rust is a language where you have not one, but two humongous technology companies saying like, not only we're using it, like the things that we build that are really sensitive from a security perspective, we build them in Rust. So, you know, that should speak to anybody that, is really concerned about authoring workloads that are hardened from a security perspective. And if you don't know much about Rust, the reason why Rust is able to kind of offer this benefit to companies like Amazon, Google, and even Microsoft, as we'll see in a second, is that Rust's focus is very much around memory safety. So far we've got Google on board, we've got Amazon on board. There's another marketing blog here from Amazon that's worth, talking about a little bit too. So the name of this blog post is why AWS is the best place to run Rust. And so in this post, they actually reference the one that we just looked at, which is interesting, but they also make an assertion here that, why Rust on AWS? Rust matters to AWS for two main reasons. One, we've already looked at. First, our customers are choosing to use Rust for their mission critical workloads and adoption is growing. Therefore, it becomes imperative that AWS provides the best tools to run Rust on AWS. So I won't read the rest of the post, but this post is talking about, running Rust in Lambda, different ways to run your Rust workloads. This is a ZDNet article, but it's called Why We Use Programming Language Rust Over Go for WebAssembly on Kubernetes app. Title's kind of weird, but anyway. Microsoft has detailed one more area where its engineers are using the Mozilla created Rust programming language, a new project from a team at Azure to test WebAssembly, which you may hear this referred to as WASM, modules in Kubernetes. Microsoft's already experimenting with Rust to rewrite low-level components of Windows, originally written in C and C++. So kind of like Google, like, operating system code, things that we really want to be secure. They're stripping out C and C++ components and replacing them with Rust built components. And is also looking to Rust's memory safety features to create a new language for safe infrastructure programming under Project Verona. So if you've used Azure ARM templates, rejoice. It sounds like they may be at some point in the future deprecated for Rust. And that's a little bit of a maybe not so much a tongue-in-cheek joke. I'd much rather use pretty much anything than ARM templates. Usually use Terraform, but that's another story for another day. So one more post here. This is from a little government agency in the US called CISA. You may have heard of them. I'm not going to read all this, but I'm going to link it. Basically, what they're talking about here is referencing, some of the major technology companies that we've already talked about, and some of their analysis of, just common classes of CVEs. And, a lot of these are memory related to, mishandling of memory and source code. So this is a really interesting article. They actually bring up Rust later because the thrust of this article is, we need more secure tools to build more secure applications. So Rust is huge. The value play with Rust is around, their secure handling of memory. So secure handling of memory inherently creates more secure applications. And, that's basically the thrust of this article. At least take a look into it. Rustlang.org is the homepage. I'll also link that in the description. This is kind of just an awareness thing for those of you that may not look into programming languages much. Rust is out there. It is growing in importance. It's growing in, obviously the big tech companies are aware of it and they're already leveraging it. So if it's not anything you've heard of, definitely go, do some more learning there. But it's nice to kind of stitch these things together and see like where it's being used by these companies and in what ways it's being used. And I think the ways in which it's being used should indicate to you that, there is definitely a value proposition there. So I just kind of wanted to bring this up and highlight it for everybody. Like, subscribe, comment, share, and we'll catch you on the next one. Thanks.